people. We're in week 14. This week you're going to need to use the compound interest formula. So I'm going to write this down here. This is something that you should absolutely put on your little cheater sheet for your test. Remember, you're allowed a one-page front and back notes. All right, so compound interest formula. Make sure that's written down. You don't want to be scrambling trying to remember this. So A equals P times 1 plus R over N. And I always put those in parentheses too, up to the N times T. Okay, so A is going to be your final amount. P is always your principal. P-R-I-N. C-I-P-A-L. Okay. 1 is kind of standard with the formula. It just kind of comes with it, like brakes on your car. T is time. It's always in years when you're using this formula. N is the number of times that you compound the interest. Remember, compound. And then R is your rate, and rate always needs to be as a decimal. Make sure to convert it. Okay, one little special note over here about your N, your number of times that you compound. So if they say it's quarterly, your N would be equal to 4. If they say semi-annually, your N would be 2. Of course, annually would be 1. So just be aware. And you look in the problem, they'll tell you whether it's quarterly, annually, semi-annually. Some banks do it monthly. That would be 12 times a year. So just be aware on your N. Okay, the question they're asking is how long? So right away, I'm alerted to the fact that we're going to be looking for T. So we're going to search for T. So how long will it take for a $5,000 investment to grow to $6,000 at an annual rate of 11% compounded quarterly? So remember, that's your N. Quarterly means 4 times a year. Assume that you never take any money out. Do not round any computations till you get to the end. And at the end, round your answer to the nearest hundredth, which makes sense. Okay, and then you can look at the list of financial formulas. But when it says compound, we're going to use this formula right here. Okay, so let's pluck out what we have here. So 5,000 is our initial investment. That's the principal, so that's our P. 6,000 is our A. That's how much we're going to grow it to. That's the final amount. 11% we're going to turn into 0.11. Okay, so let's go for this formula here. We got 6,000 going in for A equals 5,000, which is going in for our principal, times 1 plus. The rate is 0.11, 0.11. And we're going to compound that 4 times a year. And we're going to raise that to the, oh, how many years did they say? Oh, that's what we're looking for. We don't know what the time is. But we know that it's 4, right, for our N times our time. That's our question mark. So we're going to have to use logarithms to help us out with this, but let's get there. So the whole goal is to get T by itself. So we have a lot of work to do. Let's figure out what this becomes. So in your calculator, and I'm going to do this on my calculator right now, and please do this on yours. I'm going to take 0.11, I'm going to divide it by 4, and at that point I get, I'll write this down here so we can see if we match. 5,000 times 1 plus 0.0275 raised up to the 4T. Okay, now I'm going to add the 1. So then we have 6,000 equals 5,000. If I add the 1, it becomes 1.0275 raised to the 4 times the we don't freaking know. Okay, now because these are multiplying together, we can get rid of that algebraically by dividing the 5,000 out here. And of course, in algebra, if you do it to one side, you got to do it to the other. So 6,000, I'm doing this on my calculator, divided by 5,000 is 1.2. Okay, so 1.2 equals 1.0275, and everybody raised to the 4t. Okay, so that was algebra. Now we have to go into logarithms. So one of the rules in logs is called the power rule. And the power rule tells us that if we come in and put a log on both sides of the equation, so we're going to give the left-hand side of the equation a log, and we're going to give the other side of the equation a log, 0.0275. What that does is now it puts us in log land where we can enact the power rule. The power rule says we can take this up in the power, and I'm going to draw like a little dotted, and we can bring it down right here in front. That's what the power rule lets us do if you have a log on both sides, which we just gave it to. And we get allowed to do that because algebraically, if you do something to one side and you can do it to the other, then you're still equal. So what does that look like now? That's going to look like log of 1.2 equals 4 times time times the log of 1.0275. So what the power rule does, in my mind, this time up here is basically saying, nanny, nanny, boo-boo, you can't get me, right? Because I'm high above your head. But you're like, yeah, I can get you because I'm going to slap both sides with a log, and that's going to allow me to use the power rule to get you off of your pedestal and down here where you belong, right? So what's really going on down here is you got 4 times time times the log of 1.0275. The goal is to get time by itself, so you can do that by dividing away the 4 and the log of 1.0275 at the same time. So 4 times the log of 1.0275. Now, this is where you're going to have to kind of play with your calculator. So I'm using a graphing calculator. So what I'm going to do is I'm going to type in log, and then I press that button, and it comes up with a parenthesis. Then I do 1.2. Then I'm going to close my parenthesis. Then I'm going to hit divided by. And then downstairs, I'm going to type 4 times log, I'm going to hit that log button again, of 1.0275. So I want to make sure that when I'm doing this, 1.0275, that I use parentheses. So log of 1.2 divided by the log, and I'm going to use parentheses very carefully. Log of 1.2. And if you don't have a graphing calculator, you're going to have to probably figure out how your own calculator deals with logs and then do that. So I'm going to get approximately 1.68015. It says come out 2 decimal places. So this is going to be 1.68 years. So basically what we're saying, let's see, oh, actually, yeah, that's right, 1.68. What we're saying here is that for your $5,000 to turn into $6,000, that you're going to have to keep it in the bank for 1.68 years. All right, I hope this gives you a boost. We'll see you in the next video.